Hello, this is Mr. Smith. Glad to have you back. Thanks for coming by to watch. When talking about moles, we typically talk about moles of particles. So this slide is kind of one of the go-to slides, trying to compare a mole to a dozen, which is 12, a pair, which is 2, a score, which is 20, a mole, which is 6.02 times 10 to the 23rd. And it's always the same: cats, apples, eggs, and so on and so forth, and the individual atoms, molecules, formula units, ions. These are how we break apart the kind of the bigger things, the macroscopic things, into the really smallest thing possible, that still retains the properties of itself. And so these words are usually mixed up a bit in terms of our choices. So let me go ahead and scroll down to our choices of how we kind of talk about things chemically speaking, because we're not doing cats, we're not doing apples, we're not doing eggs, we're doing other things, and these are those other things. So all of the matter we have that's bigger than the proton, neutron, electron falls into this slide here. So you have our elements, and we have 118 or so elements. Let me bring that over for you. So here we have our periodic table. So we have all of these elements. You scroll down so you can see the last 28 right there. So we have these elements. Now elements are broken down into atoms, not molecules. A hand is made up of 5 fingers, right? For the most part. So we have this kind of bigger thing that gets broken down to the smallest thing possible. And so we have these 118 elements. But chemically speaking, we do have such thing as molecules. So here's some carbon dioxide. So these act as a unit. They are bonded together, and we'll talk about what bonding is later in the year, but right now they are bonded together and they are their own entity. Physically speaking, I can't break carbon dioxide into any smaller pieces. And so we use the term molecule. Molecules are made up of atoms. That's true, just like your hand is made up of fingers, but it's a carbon dioxide molecule as opposed to a carbon dioxide atom. What gets a little bit trickier are the diatomics. And remember, there we have 7 or so diatomics, starting with the number 7 and making the 7. So these 7 here are 6 of our 7 diatomics, and hydrogens are the others. Now there is the other. Now there are such things as monatomic atoms, and there are such things as diatomic elements. Monatomic elements, diatomic elements. The monatomic elements is one atom. The base unit, when you're actually counting them by the dozens or the millions or the billions, the base unit of an element is an atom. Now, with these 7, these elements really don't get any smaller. These elements don't get smaller than the diatomics. There's 2 in our diatomics: N2, O2, F2, Cl2, Br2, I2, and H2. So while there are such things as atoms of oxygen, the oxygen that we breathe in is O2. The nitrogen in the air, that's 78% of the air that we breathe, is N2. So the smallest thing that we can break down N2 into is a molecule, unless we want to start doing chemical reactions and start breaking the bonds between the nitrogen atoms, and unless we want to do chemical changes. So the smallest thing we can break down, physically speaking, for those 7 diatomics would be the molecules. So there's our molecules. This is things like water. This is things like sugar. This is things like gasoline. Most of the things we come into contact with are not elements, monatomic elements, but molecular compounds. The polyester, the cotton, these are all molecules. And again, the smallest bit you can break it down into without doing chemical reactions, without doing nuclear reactions, would be molecules. Now, we have 2 types of bonds that we talk about. We have the molecular covalent, which is multiple nonmetals bonded together, and we also have the ionics, where you have a metal with a nonmetal. So these are things like sodium chloride, calcium chloride, and the smallest bit that breaks down into is what's called a formula unit. So this is probably new from your middle school days. So a molecule is a molecule, a formula unit. So here we have NaCl, sodium chloride table salts. But when you look at one thing of NaCl, it's a whole bunch of sodiums with a whole bunch of chloride ions, a whole bunch of sodium ions with a whole bunch of chloride ions. And it's not just this one-to-one, as opposed to kind of a free-flowing carbon dioxide, CO2, roaming around that can exist by itself. Sodium chloride does not. You have a big pile of salt, table salt, rock salt, and every bit of sodium is attracted to probably 6 or so other chloride ions, and every chloride ion is attracted to 6 or so sodium ions. The one-to-one ratio that you got from crisscrossing is still true. Calcium chloride would be a 1-to-2 ratio. Calcium oxide would be a 1-to-1 ratio. The numerical ratios that you got from crisscrossing is still true, but it's not just this one little speck of NaCl. It's actually a whole bunch of sodiums bonded to a whole bunch of chloride ions. And when I say bonding, I mean ionic bonding. So the vocab is not molecule. When you have an ionic compound, which is a metal and a nonmetal, or more generally speaking, a cation and anion, we don't use the word atoms, we don't use the word molecules, we use the word formula units, which is abbreviated F.U. And then the other type, the last type, is what happens if you break apart these ionic compounds. So that is possible. And so ionic compounds are made up of ions. So for example, sodium plus. And so that plus charge doesn't make it precisely an atom. It's technically an atom, but it's a charged atom. And with the charged atom, that gets a vocab word, ion. So just one thing I wanted to show you over here. We'll talk about this later in the year, which I can make this a little bit fit on the screen a little bit better. There you go. And so here is a bunch of water molecules. The white is touching the red, so that means they're in contact with each other. They're moving around a bit. Now, if I would add in this sodium chloride, a couple of NAs, a couple of the CLs, again, the one-to-one ratio is true from the crisscrossing of the charges, but they exist as a huge pile, and call that lattice, L-A-T-T-I-C-E. It's a big lattice crystal structure of a whole bunch of sodiums and a whole bunch of chloride ions. So I drop it in, and then the water, when it dissolves, and again, we'll talk about this later in the year, can actually spread this apart ion by ion. So you can break apart ionic compounds in a bit smaller pieces, and we call those ions. Now, sugar doesn't work that way. Sugar, which has a whole bunch of covalent stuff, this is specifically sucrose. There's 2 molecules of sucrose. You can see how big the sucrose is. Let me go ahead and reset all and get the sodium chloride out of the water, get the water moving around, add in the sugar. It's a little bit of a lag. We're going to keep on trying. There it goes. And now when these get dropped in, they're going to be ripped apart molecule by molecule. Notice most of the yellow kind of stays together, the carbons, the hydrogens, the oxygens. You can see that fairly a big molecular formula there. But they all stay together molecule by molecule. If I wanted to split that up further, I would have to do some chemical reactions. And so, let me pause that, get it out of the way. Another slide that looks about the same. So here's water. Down at that submicroscopic level, you can break it apart molecule by molecule. Here's copper, metal from the periodic table. If I were to zoom in at the submicroscopic level, I'd get just atoms. And then here's a pile of salt. Again, if I zoom in, this is actually what a crystal lattice looks like. It looks like a cube with a whole bunch of sodiums, a whole bunch of chloride ions attracted to each other because opposites attract. But that fundamental unit of NaCl is called a formula unit. Here's some more pictures of some more stuff. We can spend a moment on it. Sugar is a bunch of covalents. And so that means that is the smallest part is molecules. Lead is found on the periodic table. So that can be broken down into atoms. Copper is found on the periodic table monotomically. So that means it's atoms. Mercury, this beaker here, again, found on the periodic table. They're broken down into atoms. Water is broken down into H2O, and so that is not atoms anymore, it's molecules. Water molecules are made up of hydrogen and oxygen atoms. And then the sodium chloride formula unit is broken down into ions. I'm going to skip sulfur. I could say sulfur is monatomic, but chemists actually know that sulfur is not monatomic sulfur. It's actually S8, which makes it a molecule of sulfur. So here's a chart from your textbook. A mole is a mole is a mole is a mole. 6.02 times 10 to the 23rd. Whether it's a dozen is always 12. Whether it's a pair is always 2, a bigger's dozen is always 13, a million is always 1 times 10 to the 6th, a billion is always 1 times 10 to the 9th, a mole is always 6.02 times 10 to the 23rd. So here we have copper on the periodic table broken down into atoms. Atomic nitrogen, so the nitrogen we breathe in is diatomic N2. And so that makes a molecule. 2 atoms bonded together could be a formula unit if it's ionic, or a molecule if it's covalent. But here we have nitrogen gas diatomic, which are 2 nonmetals. That makes it a molecule. The monatomic nitrogen atom is just the atom. Water, again, H2O, that makes it a molecule. Calcium fluoride, calcium's a metal, fluoride is a nonmetal, so that makes it a ionic compound. Ionic compounds are broken down into formula units of CaF2, and then within the formula unit are the ions, in this case, calcium. So we can practice a few. Here's some pictures. So here is the monatomic nitrogen, diatomic nitrogen. Here's the water, here's the calcium, here's the calcium fluoride, here's some sucrose. So aluminum is just the formula Al. And so that's the smallest bit that still is aluminum is an atom of aluminum. Nitrogen, gas, that's one of the 7 diatomics we have. When you see the multiple nonmetals bound together, that makes it a molecule. Water, good old H2O, a couple of nonmetals bonded together, molecule. A calcium ion, Ca2+, with the 2+ charge coming from the second column of the periodic table. Those are ions. Calcium fluoride, if you crisscross that using the charges from the periodic table, CaF2. Can be broken down into, probably what's the newest vocab word, formula units. And then sucrose, fairly complex structure, C12H22O11. Again, all nonmetals. That means it's covalent, and covalents are broken down into molecules. So practice this, practice the edge elastic on your own. I wish you well. Remember, chemistry is everywhere.